Good morning and welcome to our webinar this morning. My name is Graham Monday. I'm the Marketing Director for Hydrock. It's lovely to have your company this morning. Thanks for joining us. This is the first in a series of what we're calling the Carbon series, which will carry on through the autumn. Today, we're focused on design for performance. There's a strong emphasis today on new build and indeed new building for commercial use. We're going to explore just why it's so vitally important for architecture and building services to work in harmony right from the earliest RIBA stages to drive real efficiencies in energy usage and reduce impacts of carbon. And in particular today, that will lead us on in the session to look at the emerging Neighbours UK rating system as well, and what that means for developers and design teams. And that's a good segue actually this morning to say hello to our speaker, which is Glenn Irwin. He's a technical director in our building performance engineering team. Glenn, good morning.
Morning, everyone. My name is Glenn Irwin. I'm a technical director at Hydrock. I work within the building performance engineering team. I actually work across the whole of all of our groups within building performance engineering, although I'm loosely based in Birmingham. Some time ago, I heard about the Neighbours UK initiative, and I actually applied for the position of one of the members of the independent design review panel. I could see the real potential for it, and we could see how design for performance was really going to be driving new designs and could be applied in many ways to existing buildings. So this presentation is going through the design for performance approach and also goes through and touches on Neighbours UK. Okay, let's get underway. So climate emergency declarations, we've probably heard about a lot of these. There are a multitude of organisations in the UK now realising that we are in a climate change emergency. They've made their declarations, various timeframes. Some are saying they can do it by 2030, some are going to be net zero by 2050. But as you can see from this map, multitude of interest in this issue now. But what operational energy targets do we need to be targeting in order to meet net zero? Well, there's been a lot of activity behind the scenes with organisations like UKGBC, the London Energy Transformation Initiative and RIBA, and they're all pretty well singing the same thing, which is that we have to meet energy intensity targets that will drive us towards meeting the Paris Agreement requirements of 2 degrees, maximum 2 degrees rise as a result of climate change. So if we look in a bit more detail at the UKGBC document that's on this page, this document here, it's worth going through how we're going to get there, or their view of how we're going to get there. It's very easy, I think, for people to think that all we need to do is wait for the grid to decarbonise, use electricity energy for everything, and then we'll get to net zero. But as this graph shows, that's only part of the issue. In fact, the bulk of the savings have to come from this purple line, which is driving down the actual energy demand from buildings, whilst also the savings coming up from decarbonisation of the grid, from increasing use of renewables, supplying the grid, and then we kind of meet in the middle at this point here, magically by 2050. Now, in order to do that drop, now this is just worth pointing out that this was actually published in 2020. So when we say current on this graph, it was actually 2020, not 21. So we're already actually supposedly a little way along this graph here. But they're talking about a reduction in, for instance, in offices of a 60% reduction in energy usage from 2020 levels in order that we get to this point by 2050. Now, of course, a lot of these organisations are actually saying we should do that quicker than that. We should do it by 2035, but that increases the pressure on these sectors to actually reduce their carbon even quicker, because obviously, if you are trying to meet the net zero by 2035, you're actually only part way up this increasing slope here. So if you were to try to get net zero by 2035, you would actually have to reduce existing offices by 72% from current energy usage. So we can see the magnitude of the issue and how we really have to work so hard to get energy usage down from buildings progressively from now in order to meet net zero. And if we look at that a little bit closer in a slightly different way, again from the same document, we start introducing this the metrics of the DEX, which we may be familiar with, and where we need to be. And also it starts to introduce the neighbours star rating system. Now you'll see from this table, actually the key figures are these figures. And what we can see actually is for the whole building, it's a slightly higher figure because it counts the whole building in terms of energy ratings. But neighbours currently only looks at base building energy, not at the tenants. So that's why the target is actually seen to be down here, a bit tougher effectively. But in effect, it means the same thing, 35 from the base build, 35 from the total, from the tenants, equaling 70 in total, which is the same as this figure. So that's the target. But in order to get there, we need better tools to actually mirror, to actually reflect what real energy usage is going to be. At the moment, most buildings are designed for compliance, that is, in order to meet Part L, which we may be familiar with, the BER, TER percentage pass mark, which most of us know about. But that's actually just for compliance. On paper, Part L was supposed to reduce energy, and I guess there's evidence that it has done to quite an extent. But it's not the whole picture, and it doesn't look at a big chunk of things like the operational energy, doesn't look at unregulated loads. EPCs are derived from this compliance model. It's basically the same software with slightly different outputs, and it shows a comparable energy standard. Basically as a form of marketing or letting buildings to say it's supposed to indicate how energy efficient a building is going to be. But there's this thing called the performance gap, which some of you probably have heard of, and it means that EPCs don't actually reflect the reality of what a building uses in the real world. And DEX, you could say, well, they are based on metered readings, but they're only really required on public buildings, so they don't cover everything. And they also don't deal with this whole issue of with offices, with the split between who's responsible for the base build, i.e. the landlord, and who's responsible for the tenant energy. So with an increasing interest in net zero buildings, we have to have a better grip on real energy performance. We cannot any longer rely on the Part L type approach. This looks quite a complicated building, but I think it really sends a very powerful message about the inappropriate nature of EPCs in terms of showing real energy usage in the real world. So the Better Buildings Partnership did a survey of a number of buildings. Each one of these grey lines is an actual building as recorded in the real world after it's been occupied. But each of them has been grouped in accordance with how at the design stage what their EPCs were actually rated to be. And if we draw an average for each of those group of EPC ratings, we get these median, if you like, average green lines here for each of those blocks of EPC scores. Now, you may fairly quickly have already realised that actually, if you look at the average for an F-rated group here, is actually lower than the average for an A-rated group, which clearly shows that EPCs are a bit of a nonsense in that, you know, you could have buildings that are supposedly going to perform the lowest, worst possible energy performance, and they're actually performing better in the real world, better than those that are A-rated. So I think this is a really powerful slide, and one that was presented to us by the BBP as part of our neighbours IDR training course. The future of EPCs, I think there's definitely in some doubt. This consultation came out a little bit earlier this year. It's closed now, but the BEIS, you know, issued this consultation, and they are clearly thinking about other options for measuring and rating the energy performance of buildings in commercial and industrial buildings. The document itself is peppered with numerous references to Neighbours UK. So I think the writing's on the wall that we're going to see the end of EPCs eventually. They have to bring in a more accurate, more representative form of showing people, potential buyers or letting agencies, what the real performance of a building will be. So just to go a little bit more into the performance gap, and we know that buildings typically consume 2 to 4 times the predicted energy as in the compliance model. The compliance modelling doesn't count unregulated energy such as plug power or small power, if you like, lifts, external lighting, servers, process loads, things that just don't go into conditioning the space itself. Discrepancies between design specification and as built. We can design facades to perform in a particular way, but with plenty of evidence that actually don't always get built that way. Hence the use of things like thermal imaging to reveal where buildings are not actually built to the standard they were designed. And that does make a big difference. Occupancy is a big issue. Often buildings are occupied for longer periods than the original compliance model assumed. There's obvious reasons for that, but that just doesn't go into the calculation. So that does explain quite a lot of the performance gap. And there's a lack of real energy data. We just don't go back to buildings enough and test them. We just don't do it regularly enough. I get involved in post-occupancy evaluations or POE, and we're just not getting commissioned to do enough of these. People are just seeing it as a nice to have, a sort of a bolt-on extra that when the money's short, they just cancel that straight away. And this is really the only way how we know how buildings are really performing. So to get closer to reality, we're proposing the greater use of design for performance. Coming on to neighbours, no, it's not that neighbours. I know you're all thinking it. It's quite interesting that, whenever you mention the word neighbours, this is the image that comes up in everybody's minds. Maybe we should have competition to see who can name the characters on this slide, but that may take a little while. I'm old enough to remember the original crew. But it's quite interesting how this originated in Australia, and it was interesting that how they realised that by coining the term neighbours, it would actually provide a bit of a marketing hook, and it would raise the awareness of this because everybody was aware of the Australian soap. So neighbours stands for the National Australian Built Environment Rating System, and it's been a rating process in Australia for operational energy since 1999. It's been incredibly successful. The scheme now covers 86% of all Australian offices, so huge market saturation over there. Its use of landlord services, as a result of its use, energy and landlord services has dropped by 36% since 2010. And I think the UK has been very envious of that. We've been looking at it from afar and thinking, yeah, we need something like that over here. The Australian market really values the neighbours ratings. They have faith that it reflects real energy performance and it aligns with the whole design for performance approach. And what's driven that? Well, it actually was originally driven by the market, but when other things came in, which we'll come on to, that actually kind of gave it that turbo boost and really up the uptake of it across the whole of Australia. So it's about this kind of virtuous circle of the occupiers understanding that this thing has some value in it and it's real and it measures real energy. The investors need to provide buildings that, they need to invest in buildings that have that value. So the developers have to then compete with each other to get the best possible rating for a given price or a given building type. The supply chain then has to build those and they understand the value of it, and it'd be foolish not to achieve that. And then the leasing agents obviously recognise the value of it in terms of either selling or leasing properties. So the whole thing goes round, it's self-generating, but it really took off. This dark line is the average neighbours rating for offices in Australia across this period, and it sort of trundling around sort of upper 2s to 3s, getting towards 4s, and they took a little bit of a dip. But then to start with, it was actually mandated by Australian government for all of their leases in 2005, which is this sort of uplift here. And then once it became generally compulsory energy disclosure in 2011, you can see here that it really took off in terms of the drive the market made in increasing the ratings across there. And obviously at that point also this orange line, the steady market penetration to the 86% that we just mentioned. Neighbours since expanded into all kinds of sectors, not just offices in Australia. So it deals with things like apartments, data centres, shopping centres, public hospitals and hotels. If you're in a lift lobby and a building's got Neighbours rating, everybody's proud of what that rating is. You will see these kind of billboards in a building that has a rating because they're proud to display what it actually has achieved. So Neighbours UK, it was brought over and launched at the back end of last year. There was some big names involved up to that point, a lot of pioneering developers and property companies, and the big names within the industry were also supporting it right across the board. You know, we talked about UK GBC, BCO, RICS, all those kind of organisations were well involved in this process and right behind it. And there's currently 14 flagship projects spearheading Neighbours in the UK. The vast majority of those are in London, as you might expect. Interestingly, one of them was in Leeds and one was in Manchester. And we're starting to see it now creeping into the regions as something that people are starting to talk about and clients are demanding. Neighbours was launched in the UK in November last year. We were still in our training process up to that point for the independent design review panel, but a lot of activity going on. There was a webinar, the original launch, and you know, it was most notably there were loads of investors involved in that webinar. I really wanted to see where the market was going. So the original scheme ambassador was the Better Buildings Partnership, as we mentioned. The BRE were then in November actually announced as the scheme administrator. The scheme is still owned by Neighbours, as in the Australian organisation. So what's the process? Just to go through this very quickly, it is quite involved as a legal process. You have to sign legal documents to which, you know, these are design for performance agreements. Everybody has to be on board with this. The client has to understand what they are committing to, and ideally they should be stating their preferred Energy Star rating for their building development at this early stage. Then at that point, when all the paperwork's signed up, they're actually able to promote it as a target rating, not an achieved rating. It's a long way off yet, but they're allowed to tell the world that they're attempting to build a building that has a certain star rating. Now, stage 3, this is quite an early stage for us as M&E engineers in terms of the design process, but we have to put a lot more effort in terms of the design, the modelling, advanced simulation of the building design at stage 3. And that is the sweet spot in terms of it's sufficiently detailed enough that you can actually understand what the design is going to be and what you need to tune and adjust, but it's not so far advanced that it's too late that you can't change anything. And then equally important, this is the independent design review, and I'm a member of this panel, which we'll come on to. At this point, the client has to approach a member of that design review panel to agree, to ask for quotes and then agree who's appointed to each job. As independent, they can't be part of the design team that exists at that point, and they are a bit like a coach. They have to help the design team deliver the star rating that it's actually been committed to right at the front. And it's not until the building's actually been occupied for a period of time that you get your rating, and then you can tell the world you've actually achieved a certain rating. So it's a quite drawn out process. You know, you can't just say, right, hand over the keys, we want this rating. That will not happen. This is about real data. So you have to have the real meter readings in order to clarify the performance before you get your rating. And interestingly, I think the real power of Neighbours as compared to DEX is the way it deals with this old issue of, you know, the landlord blames the tenants for an inefficient office because they've got things stuck on full power all the time, and the tenants blame the landlord, saying, well, if the base plant and the actual, you know, chillers and boilers were a bit more efficient, maybe we'd score better overall. And that's always been this issue of one side pointing the finger at the other. I think the really powerful thing about Neighbours is that it demarcates the two, gives you very clear guidance on what's in the tenancy side and what's in the landlord side. Now, just to make this quite clear, all of the building HVAC loads are included in the Neighbours rating, even the HVAC loads within the tenancies. However, lighting, small power and ICT is excluded because that's included in the tenancy side. At the moment, we're only looking at the landlord side, the base build side, and that would include, as we say, all of the HVAC, lifts, common area lighting, and hot water. So just because base landlord areas does include tenant HVAC, excludes, as we said, lighting, small power, ICT, and it avoids this issues of responsibility for consumption. And in the very near future, we're hoping to see a tenancy rating also being available in the UK. These are the documents. These are the documents that we had to pore over and be intimately familiar with every last clause, and there's a lot of it. And I think that's the power of the independent design reviewer. We are familiar with all this process. We're familiar with all the rules and how it's actually calculated. And so we're best placed to actually advise design teams as to how to achieve the rating. I'm not an assessor. An assessor is somebody that comes along later on and actually says what the rating is. So, you know, need to understand the difference between an independent design reviewer and the assessor. They're not the same role. The assessor is another person again, and they're going through the training process of that at the moment. So coming on to this modelling and simulation side of it, Neighbours adopts a digital twin type approach, which is basically a very complicated simulation. Excuse me, just a glass of water. So you set targets at the start, and that's really your design for performance agreement. You can do some early stage modelling. This isn't actually a definite requirement of Neighbours, but I think our approach to design for performance is actually buildings benefit from some early stage modelling. That helps set the concepts, helps get the architecture working right, orientation, even site selection, things like that can be done at that stage. So it's really important to do those early stage concept models. Then we start getting into, as we said, RIBA stage 3 is the kind of key point where you really do a much more detailed simulation of the building and its systems. You have to look at all the controls, the set points, how the systems function. That all goes in the model, and that can be tweaked and adjusted. And so this is not just about producing a model that gives an answer. It's about playing with that model and tuning it and working out how we adjust all these things and how we alter the design and the settings in order to get the best possible performance. Then when the building's built, we're looking at the meters. That's really the assessor's job to then look at the actual performance compared with the predicted performance and see how closely it matches up. And generally, the Neighbours and the design for performance approach is much, much closer than we see with this performance gap. So it could only be in the region of 5 to 10% different from what actually the simulation said the energy consumption would be. And there's this process of going back, tweaking it, adjusting it to see if we can actually reduce that margin even closer. So typically, when the building's finished and handed over and assessed, it might be within a couple of % of the actual simulation model. So Neighbours modelling has a whole bunch of rules that we've just seen from the previous slide in terms of the documents that you refer to. But basically, it's following the line of a digital twin model, which is very much at the heart of design for performance. So they're very similar in that respect. And we do prefer to use early stage modelling and digital twins on all of our design for performance projects, not just for offices and not just for Neighbours. So here's the panel of which I am a member. There are 11 of us only currently in the country. So if you're doing a Neighbours rated project, you will need to employ one of those 11 people on your project in order to do the process. Neighbours for existing buildings. I think there's a lot of focus inherently on new build, but actually what we're seeing abroad in Australia is that existing buildings are equally important. And actually, in terms of the carbon challenge, they are the bulk of the stock that are going to be here by 2050. We all know that. So that's just as an important challenge. But what's going to drive property owners or leasers to actually want to get a Neighbours rating on an existing building? Well, because I think the value will start to come through. We've seen this in Australia. There is probably more activity in existing buildings than there is in new build. And When you first rate the building, you'll probably find it's a relatively mediocre 2 or 3 star rating without any upgrades to the energy performance, without any tweaking of the systems. So what do? Well, 4 stars are probably going to be what the market's going to see as the kind of minimum. That's going to be seen as good, and really the kind of minimum that you should be telling the world about. Anything less than that, you might be slightly embarrassed to talk about. So how do we do that? Building optimization studies are the solution. And so engineers like myself would go into the buildings, interrogate the usage, find out where all the energy is going, and then develop a suite of upgrades, interventions, ideas. Sometimes it's not even actually a physical change. Sometimes it's just about resetting things in things like BMS to make sure everything's working as it should do. But usually big savings can be made from these investments into optimization studies, and that will uplift the star ratings to something closer to 4 or even higher. And this is common practice in Australia. It's the route to improving asset value and lettability. They're finding that building leases go quicker. They find that tenants stay in those leases longer because they're proud of those ratings, and they find that the asset values are higher as a result of a NABERS rating. I'm not going to go through all this list, but typically there are a whole raft of things that we see when we go into buildings to do optimization studies. I guess if I had to pick one, probably the biggest is the BMS. That's probably the biggest cause for energy wastage in buildings in UK at the moment. But lack of metering is something that does need to change as well. So what does this mean for designers? Well, obviously, if the BRE are administering NABERS UK, then there's going to be a big dovetailing into things like the BREEAM E&E credits, which deal with energy side of BREEAM. That whole meshing in of those two schemes will be much clearer and simpler, and therefore you will kind of just need to do your NABERS simulation and you'll get your credits for the E&E quite quickly and simply. NABERS, my prediction is probably we'll see the end of EPCs over the course of the next 10 years, maybe quicker. And there's all the writing on the wall that it will replace the approach for building regs approval. You know, if you had a 6-star rating on a building in the UK, that would be really something, because that is really, really a very good standard. There are very few in Australia at the moment, I hasten to say, but originally it was 5 stars, and they had to actually increase it to 6 stars because the market was responding. And as we saw right at the beginning, that's really the target if you're heading for net zero. And the brand has this value, and we see the UK investors are really interested in this. So it will cut through all of that greenwash about how buildings purporting to be sustainable. This will be real. It will be tangible data. It's auditable. It's qualified. It's precise, and so it will have that value. And I think the market will respond in the UK. I think we as designers have to do more holistic design. You know, I used to do this years ago. It kind of waned a little bit, but I think a lot of these sustainable approaches to holistic design will start to come back to the fore. We have to squeeze every last bit of design out to optimize the building. And the greatest gains are obviously made at the very start, when we're at this sketchy sort of stage. But equally, we can develop simple models to help guide that process as well. It's perhaps not that obvious that if you build tall, slender buildings, they're going to consume more energy than narrow plan, lower rise buildings. There's lots of reasons behind that. And what will be revealed from this is that probably we'll start to see, not to say you can't build a 20-story building, but you're going to have to work so much harder in order to get the same star rating than you would do for a lower rise building. And that could cost more money. So if you're looking at optimum star rating per cost, it's likely to drive down the height of buildings, not increase the height of buildings. Narrow plans, we know, much better for daylighting, better opportunities for mixed mode, natural vent. There's a big push into that area now. You know, just because a building has air conditioning doesn't mean to say it has to be on 365 days of the year. So we have to find all these avenues to make buildings more energy efficient. And there's much more of this usage of digital twins. You know, our modelling department are ever more busy now producing these. There's a demand for it, and we are seeing the value in that in terms of our M&E design options. You know, I think we talked about built form and orientation and things like that, but it also comes down to facade design, glass coatings, the percentage of glass, and shading. Good old brise soleil still has a place and is still very useful. Facade insulation is inherently moving towards Paso standards of insulation, very good levels of air leakage, and these things are tested, but build quality must improve. It's all very well doing this on paper. It has to be tested and proven to be performing to that standard. Fully glazed buildings, I'm not saying they're not possible, they are still possible, but as with high rise, you're going to have to work that much harder to achieve the same star rating. So are we going to continue to see buildings like this? Maybe we're going to see more buildings like this, which is the UKHO headquarters that we've recently won the BCO award for. So maybe this is the future rather than this. In terms of the M&E kit, we're going to see things like heat pumps becoming the norm. We're seeing far less gas supplies going in now. People are conscious of this move away from fossil fuels, and renewed interest perhaps in ground source heat pumps, because they will improve again on top of air source heat pumps in terms of their overall performance. Not always applicable to every site, but I think there's a renewed interest in ground source. Advanced heat recovery, I think, if we're building mixed-use developments, there's tremendous opportunity to have district heating, district cooling, or ambient loops which share energy between the different buildings. So it's going to, there's nothing better than to take heat from one area and reuse it in another, rather than generating a heat form from scratch and using fuel to do that. More passive systems, there's an increased popularity of active in-slab cooling systems, or the old systems like passive chill beams are starting to come back into the fore. I'm not saying you can't go for your classic fan coil systems, you can, but as with tall buildings, as with fully glazed buildings, they're going to be harder to achieve a good star rating, particularly with fan coils, because of the fan power involved. We'll have a lot more meters on buildings, that's a definite. That's the whole ethos of Neighbours. You have to meter everything, and we'll spend more time in stage 7 tweaking, going back, fine-tuning, and getting buildings to perform closer to the original simulation. Okay, sorry about the faltered start. We'll get on to some questions now.
Glenn, thank you so much for that. That was great. Thank you. Yes, we have a little bit of time, but I don't want to eat up too much time for people into their days. Glenn, probably predictably, there are a number of questions that do focus on Neighbours. I'm also just going to answer somebody's question there that says we do share a recording of this, by the way, afterwards with you all as well. Yeah, the questions that particularly have come in, and let's go through a couple of these very briefly before we wrap up, are predictably particularly about Neighbours. First of all, is there and Glenn, I don't know whether you know this, is there a fee to use Neighbours on a project?
Yeah, there is. I'm not quite sure what that fee is. It's all fairly new, but that is basically to cover the administration of the process, just as you would do with a BREEAM project. You have to pay the BRE a fee for their management of the administration of it. So yes, there is. I can't honestly tell you what that percentage is or what that would be on a big building. It's also new. I don't think anybody really knows yet, but I'm guessing it's going to be, it's not going to be a tiny fee, but hopefully not disastrous either.
Okay, thank you. And then another question, which again I suspect is also where Neighbours is so new to some degree. Someone has asked here about whether Neighbours is how Neighbours is going to be rolled out to contractors and subcontractors so they can upskill in the process, which is an interesting question, because you've talked a lot in this presentation about that, the importance of the most early stage of design, and obviously you've been through this process on Neighbours, but I mean almost the question there is, how does that flow through the supply chain?
I think it's a really important point, and having come from working for main contractors about 18 months ago, I understand what it is to deliver more efficient buildings on site, and they have got some challenges. I think we inevitably see a lot of these energy saving features, and things like meters are kind of wheedled away. They kind of evaporate in the design before the building actually gets built. neighbours is much more controlled, and the contractors will be brought into the discussions, I think, at much earlier stage. They have to be, in order to try and, you know, help make it more deliverable. They have to upskill in terms of what's going to be expected of them. Inevitably, it will put more pressure on M&E consultants initially to kind of upskill the supply chain as to what they really have to do. There are other initiatives like soft landings and things like that that really kind of dovetail into things like neighbours, because it helps deliver a building more efficiently in terms of handover. But I think in terms of how they will respond to the tender designs that are sent to them, which will incorporate all of the requirements for neighbours, and it will be much more involved and much more complex, and more effort has to be done in the simulation at a much earlier stage. I think it probably will mean that M&E consultants have a bigger role even in D&B projects, where they will have to provide that guiding hand through this, you know, more complex process.
Okay, thank you. Great answer. Okay, I'm going to take a couple more questions here. One from Susanna, who said, and it's interesting because Glenn, you talked about in Australia the fact that it has the rating system has spread now from offices to so many other uses. But interesting question for Susanna, which is very typical and very relevant at the moment. There is quite a repurposing of commercial non-residential buildings into pure residential or mixed use retail residential blocks. Will the neighbours approach work for that kind of thing? I mean, we have already said we're right at the starting gate here on new build, let alone onto existing stock. But any observations on that, Glenn? Well,
in Australia, they have a different system for residential. I think it's called NETHERS or something like that. It's similar. I think it's NETHERS. They have a completely different rating system, which I'm not very familiar with on the residential side, and it's not included in the neighbours group of ratings. But design for performance can be applied to any kind of building, and it's very parallel to neighbours. It's just not so constrained and controlled. And part of that constraint and control is, as I said, this demarcation between the base build and the tenancy side of it. If you're in residential, I guess there could be the same issue. You've got tenants maybe in a block of apartments and the landlord who's running the base equipment. So, but it's not the same system in terms of residential. You could apply the principles of design for performance. You could apply a digital twin and simulate to the same level. But I think it's unlikely you would do that unless you have a client that's particularly passionate about that. And we do find that residential is often quite cutthroat in terms of costs and delivery, and so I think it's probably one of the last sectors where that type of approach would come to the fore. It's going to be the investors seeing the value of it and being able to market it, I think, is the big thing. Okay, I'm going to try and take, if I may, 3 more questions. We're going to be quick fire, Glenn, on this, okay? Here's one which I can't actually remember whether you said. I've heard you say this before, but I'm not sure whether you said this in this presentation. Are buildings continually monitored to update the star rating? So, as this person said, if refurbs are undertaken to tenant areas, for example, what happens? I think, and I need to check this, I think it's re-rated annually. I could be wrong, it might be a longer period than that, but they are regularly re-rated. So, you know, you have to maintain this. And what I think the challenge we see in Australia is that they continually go back to buildings and say, okay, we've achieved 4.5 at 12 months after handover, 24 months after handover, we got to 4.7, and 36 months after that, we got it to 4.8. You know, so they're proud of the fact that they have to keep going back and actually improving. And I think that is really powerful, because we see things like EPCs, you know, are valid for a certain number of years. The building may be performing nothing like that by the time it gets to the end of the validity of that certificate. So, yeah, it is constantly renewed. Yeah. Okay, that's good. Well, we like it. We like a bit of competition, so that sounds good. 2 final questions, putting you on the spot here. Martin Simpson asks, is Neighbours in competition with BREEAM, or does it work with BREEAM? I think, as I said, it works with BREEAM. BREEAM is obviously covering much broader scope of environmental issues. So you're looking at things like waste and pollution and all kinds of stuff. materials. Neighbours is not looking at that. Neighbours is only looking at energy consumption. So what you will find is that the neighbours will dominate the E&E sections of BREEAM, and as we said, it will dovetail into that. So rather than having to do other types of simulations, the neighbours simulations will automatically qualify for E&E credits without having to do additional work. So it dovetails straight into the E&E section of BREEAM, but is obviously not covering all of the broader sections of BREEAM.
Okay, and one final question, and I love this question because this person is said is anonymous, obviously feels quite passionately about it, but it covers an interesting point you've made in this presentation. This person says, how can we lobby to remove EPCs as fast as possible and replace with a real approach like neighbours?
Well, I think the answer is you should have responded to the consultation, because that's exactly what the BEIS were asking the industry. What did you think about this? Do you think we should be going down a neighbours type approach, a design for performance approach? You know, it was incumbent on all those who had a vested interest to respond to that. I guess it was probably poorly responded to. In reality, we're all very busy people, but I don't think you need to lobby that hard, because my view is the industry will respond and EPCs will become irrelevant. They will be just, if they remain in any shape or form, people will just dismiss them as a complete waste of time. And eventually the government will get the message that they're wasting their time asking for these things because they don't represent real energy.
Okay, super. Glenn, thank you so much indeed for that. I hope people found that really valuable. Thank you for your time. Thank you to everybody for joining our session today. It's been great to have your company and those great questions at the end there as well. We will be sharing the slides and a link to the webinar, and we will follow up with more information on our carbon series in the autumn as well. Just leaves me to say, I hope you have a great day. Thank you.